Okay guys, here's just a quick, hopefully short video on a few things that I have and how to use them. And hopefully there'll be more instructional videos to come. Those of you who are familiar with Arduino, probably all of you since you're watching this video. So this is a programmer. Shout out to Kevin Dara who created this programmer. It works great. And I made this little temporary board here to plug this into. And like I said, it worked great. The problem I ran into when I'm breadboarding things is that this wants to flop around. And some of my projects I need to be able to move and test. So I created these, which are basically that in two parts. And this allows me to snap this down into a breadboard. This as well. I've got power, data pins, and then ground and power broken out. And they will actually snap down into the rail. The outside one is ground, as you see here. So try to make sure you don't reverse it like if I did it on this one. You see the power is on the outside. So if I snapped it down here, it would be reversed. It needs to go over on this side. Now, knowing that, I went ahead and used it this way, and I just had to make sure I remembered that this was no longer positive. But anyway, so that's those. This is also available, but it is only a breakout board. It does not have any supporting electronics on it. However, this is what I would call a Leonardo Mini in essence. Fully broken out, has all the supporting electronics. So literally when you plug it in, it will be recognized as a Leonardo in the computer. A couple big things different is that any of the minis that I found, including the full-size Leonardo, does not have all of the 32U4 pins broken out. This one does. The only pins that don't go out to the headers are, of course, like the crystal or the USB pins. Also, this has a full-size USB connector. Like I said, one of the big pushes for me on everything that I've done is to try to make things that are securely connected so that as I'm testing things, they're not becoming unplugged or you're getting the typical Windows da-donk because it's disconnecting from USB. So full-size USB, fully broken out. And it also is breadboard compatible, as you can see. So now you can plug it in and you get a solid mounted Leonardo. And here I'm working on a project where this is an atmega 328p, and I'm using the Leonardo to program that. Just like if you had an actual Uno, you got the 16U2 here that is used to connect USB and then run your your program to the 328p. Same idea, it's just a Leonardo instead. Speaking of this one, I also have these available. These are Arduino Stackers, as I call them. Basically allows you to push down into whatever Arduino format you want to use, whether it be the Uno, Leonardo, or even you could even use it on a Mega. To be honest, it would just stick out here. And then you can put over top of it another board. And what it allows you to do is have the headers from the bottom one broken out. So if I remove this board here, you can see how they are broken out one to the other. So you can run a program on one board, run another program on another, and have them interacting with one another. And these will come with spacers so that, again, it can all be bolted together into one solid unit and not have two units side by side with jumpers running back and forth kind of like this. Because obviously you can't snap these into a breadboard. The other thing I have is, I'm sure many of you may be familiar with this little device. Great little product available on Ftdi. Not mine. I've used it for a long time and allowed me to run grbl on an Arduino Uno. This is not an Uno, this is Leonardo, but same form factor. Anyway, And it worked great. Problem I run into is that I had to have my Uno constantly connected to my computer running my CNC device. Also, this wasn't a bad price for this. I think it was $10 or so. But you got $10 invested in this, plus you got another 35, $40 or whatever invested in this. So you got 50 some dollars plus the shipping on each one of them. Of course, I did this before knockoffs were available. And it's decent, but it's good. It's good size. So what I decided to do was to create this device. Nearly half the size. In essence, it is a full-fledged Uno with a 16U2 and 328p ISP headers. But the biggest benefit is, again, full-size USB connector, plugs right in the back of the parallel port on the back of your CNC machine, and now you have a self-contained, small contained grbl device. The other thing I would like to share that I've been working on and is available is a little programmer. I guess it's not that little, but it's 328p running USB-ASP. And what this will allow you to do is to take any 328p or any chips that you want, snap it down into the ZIF socket, and headers go here, and therefore you can connect from ISP, which is broken out here and here, and connect the individuals that you need to program that chip. This does a couple of things. One, if you notice, there are two crystals here. One runs this, the other is broken out here, so that you can then actually, if you happen to have your fuses set for external crystal, you can access that crystal and use it to run the full 16 megahertz crystal on a chip. Another couple of things, if you ever did want to do your own firmware here and didn't want to use USB ASP or do any sort of updates, quite literally you could take this chip off, plug it onto here, and then use a little USB ASP programmer or any other program you may happen to have and connect it to, say, these pins here for the ISP ASP, which are broken out here as well, and then it would be able to program whatever chip is on here. So if you move this one over here, or if you do a different one and keep this one original. The other flip side of that as well is that this is your standard 6-pin ISP connector, like on your Arduino. This is the 10-pin that is normally on the USB ASP. So it could be connected directly to that. So you can connect to either one. They pretty much are identical and connected to one or the other. Also, again, full size USB connector, so it's a solid connection. This will over here will allow you to provide power to the chip, or if you wanted to and didn't want to put chip in here, you can then jump from here to your device and actually do in-circuit programming if you wanted to. This comes in two versions. I think this is the one I currently have on Ftdi. The other version will be basically this board, but instead of that connector, it will have this one with a longer set of headers, and it will allow you then to connect a bigger board, or they make adapters that allow you to put these chips in them, and it will literally snap into this zip socket as well, and then you can jumper over your ISP and program your TQFP chips. So that was pretty quick. I ran through it all relatively quickly just to try and get it done. I may do some more tutorial related videos pertaining to these things. Of course, I've got other ideas for videos coming out, things to do with CNC machines, lasers, even some automotive stuff. So hopefully this is helpful. Hopefully you enjoyed it. If you did, give me a thumbs up. feel free to subscribe. And if there's anything you would like to see, leave comments below, and I will be sure to put a link in the description so that any of these things that are currently available on Ftdi, you can feel free to pick up. And I may even do videos specifically as tutorials on how to use them, each individual thing, so that they are freely available for use to anyone who has purchased them and may want to see how to use them more in depth. Thank you, and have a good day.